Hi everyone, I'm Sharif and I'll be taking you through the adversarial search. When you talk about adversarial search, this is a type of search problem in which agents are often in competition against one another, and their goal are directly opposite to the goal of the other agent. It's usually used to find optimal strategy in competitive environments where multiple agents have conflicting goals. This statement just affirms the definition. So you just take a scenario like in a football pitch where one agent has to score for them and defend for them to win. In real world examples, one you might think of is security and fraud detection. The defenders, these are usually the cybersecurity professionals. The objective is to predict or is to protect the system, while the attackers, these are the hackers, their goal is to just breach the system. So the professionals, cybersecurity, can use the search to predict and counteract potential cyber attacks by understanding the strategies that the malicious attackers do normally use. And then the other, it can be applied in economics and business, where two companies might be competing to capture the same market share by adjusting prices, advertising, and product features. So investors do anticipate market moves and counter moves by competitors, whereby optimizing their trading strategies. And then when you go about the mini-max algorithm, this is used to minimize the possible loss for a worst-case scenario. Take an example where a player is trying to maximize their score, while the opponent is trying to do what? To minimize it. So the algorithm assumes that both players will play optimally. You can just explain it as the players expected maximum payoff. And the best example for this algorithm, it is in the chess, is a classic example where one player's move, the max is countered by the best player's, the opponent's best move, which is the mean. The goal is to find the move that maximizes the player's advantage while minimizing the opponent's advantage. And then in the expectee algorithm, this is an extension of the minimax, but there is an addition of the third node, which is the chance node to represent the randomness or the uncertainty. The best example is the dice game, where the move is not entirely determinant on the player's move, but also the score on the dice roll. And the algorithm calculates the expected utility. Then the other, when you talk about the alpha and beta pruning technique, it is a technique used to optimize the minimax algorithm by eliminating the branches in the game tree that do not need to be explored, like they don't need to be used. It effectively prunes the large parts of the tree, which speeds up the decision-making process without affecting the result. The main purpose is to reduce the number of nodes evaluated in the search tree, thereby improving the efficiency of the algorithm and while still finding the optimal move. It does this by keeping track of two values. One is the alpha, which is the best value the maximizer can guarantee, and the beta, which is the best value the minimizer can guarantee at any point. Then for the best, the example that you can give is take a scenario where a player is playing, like in the chess move, which will lead to a bad move, whereby to get them a loss. You understand? So if that player can see that, can notice that early, and there is a better alternative of the move, better alternative, they can go with that, which will pull out the other branches of the other move that was the bad one, whereby also affecting their decision process. Thank you.